Howdy, this is Jim Rutt, and this is The Jim Rutt Show. Listeners have asked us to provide pointers to some of the resources we talk about on the show. We now have links to books and articles referenced in recent podcasts that are available on our website. We also offer full transcripts. Go to jimruttshow.com. That's jimruttshow.com. Today's guest is Joscha Bach. He is Vice President of Research at the AI Foundation. He has previously been a research scientist at MIT and Harvard. He is author of the book Principles of Synthetic Intelligence, Psi, that's PSI, an architecture of motivated cognition, and he has published many papers. I also have to add this. He has one of the most interesting tweet streams that I follow. You can follow him at Plinz, Plinz, and only some of it has anything much directly to do with artificial intelligence or cognitive science, but it sure is entertaining. He's certainly in my top handful of tweet streams that I enjoy following. So let's start with understanding sort of your motivation. How did you get into this? And here's a quote from one of your talks. Maybe it's from a paper, I don't remember. You said, "We need to understand the nature of AI to understand who we are."
Yeah, I think that artificial intelligence as an idea is, in some sense, the missing link between philosophy and mathematics. It's the attempt to make the execution of processes that allow us to use language and make it refer to meaning automatic and understandable and scalable. And this basically allows us to ground our use of languages that have meaning in machinery that we understand, in a mechanical universe. This idea that the universe is mechanical might sound limiting to many people, but it's not a very limiting idea. It simply means that the universe is not magic, that it's not built over symbolic correlations or symbolic causation, but over things that have no conspiracy inside of them. And the other thing is that if you think of yourself as a system that has no conspiracy inside of it, what kind of system is it? And AI is the attempt to build a testable theory of what that is. And if we are able to test that theory successfully, we will have built a system that in the ways in which it matters is going to be like us, which means it's going to be a system that is able to reflect on its environment and its own role in it and make a model of that, understand that, and understand its own nature as well, right? So this project of artificial intelligence, in my view, is something like a capstone of a certain philosophical tradition, or maybe of all philosophical traditions, of the question of what are we in this universe and what's our relationship to the universe that contains us? What is the observer? All the other questions come from that. And so it's, in my view, the most important question there is.
Yeah, I have to agree that as I've gotten into artificial intelligence, particularly artificial general intelligence over the last about 6 years, I've started digging into it in some depth. I've found myself being forced to ask just those kinds of questions, which kind of surprised me, right? And of course, we both know that not everybody interested in AI is interested in it at this kind of a level. I mean, there's an awful lot of narrow AI these days, which we'll talk about later, the distinction between cognitive AI and narrow AI and artificial general intelligence and more applied things. So I take it that you would consider yourself not just an AI guy, but also interested in artificial general intelligence.
I think that artificial intelligence is an attempt to reboot the original idea of artificial intelligence. It's basically AGI and the original AI are the same thing. When AI started out as a field, it was done by a number of people across disciplines. There were some cyberneticians, there were budding computer scientists. Computer science was just getting started. Some information theorists and even psychologists involved in the whole thing. And the idea was we now understand how computers work. We understand that everything that we understand, we can express as constructive mathematical paradigm. Constructive mathematics is the part of math that works, and it happens to be the same as computation. So let's go and teach the computers how to think. And the first generation of people that set out to do this were very optimistic. They basically thought this is going to be an extended summer project, maybe a couple of years, then we will have made tremendous progress. And as it turned out, they did make tremendous progress with hindsight. So they did a lot of amazing feats. Like, it didn't take that long to teach computers how to play decent chess, which means chess that is much better than make abilities, even before computers became superhuman at chess. And how to get this thing to do very simple language understanding, simple planning, and so on. This didn't take long. A set of programming languages that we use today, almost all of them have been invented in their structure and principles in the first couple decades after AI has started. And the effort was very much connected throughout computer science. So in some sense, almost everything that didn't work in computer science was AI. And when it worked, then it became something boring. And AI has, in some sense, has been always the pioneer battalion of computer science and very, very productive as a field. But most of the people that worked on it realized that this optimism of building a machine that thinks in a short time, that is, for instance, within the time of a couple grant proposals or even your entire career, that's very daunting. It's probably not going to succeed. So they're focused on things that we're going to give results within the duration of a grant proposal or within the duration of a career. And these are also the things that were going to give you tenure. So AI became more and more applied, more and more narrow. And it was about improving the automation of statistics and developing mathematics around that and theory around that and so on. And this philosophical project itself has only captured the attention of relatively few people in the field, as philosophical projects happen to do. I think in some sense that's correct and it's the right thing to do, because philosophical projects are daunting, hard, risky, and often have only marginal benefits. So why not go for the thing that gives very tangible benefits right here, right now? And this is what the majority of the field did. There are also some political upheavals within the field that happened, right? When Minsky claimed that cognitive AI was in some sense the same thing as symbolic AI, I think he made the wrong bet. And Minsky was somebody who was an extreme visionary, but he was also somebody who was not so interested in the visions of other people. And so he basically screamed at people that did cybernetics and that did neural networks and actively delayed the development of dynamical systems models of cognition and of machine learning systems for more than a decade. Basically, who moved the funding for neural networks and apparently also impaired the funding of cybernetics and contributed to the ending of cybernetics as a field in the US to get more, I suspect, funding and airtime for his own approaches. And in some sense, it's not his fault that he could not see that he was not right, that his approaches ultimately would lead to difficulties in grounding concepts and building an understanding that goes beyond symbolic systems. But he inadvertently created a division between cognitive AI, that was his own followers and disciples, and everybody else. And so the other people did not read Piaget anymore, and they did not think about psychology very much anymore. And this division within artificial intelligence between people that think about cognition and psychology and people that think about how to, for instance, process images and that how to interact with an environment, this division lasts until today in many ways, even though it's the gap is closing more and more.
Yeah, and yet, if you talk to people, even at Google, they will admit late in the afternoon or after several beers that the reason they got into the field was something like AGI.
Absolutely. When I entered university, I only did this because I wanted to understand how the mind works. And that's why I studied computer science and philosophy and a few other things. And it was very disappointing to me to see that philosophers were completely not into this, mostly didn't understand the ideas that computer scientists had developed during the last 50 years at all. And if so, then only in a very superficial and derisive way. And the computer scientists were not interested in philosophy. And it was really depressing to me. And I was not alone in this. So when I was a grad student, or not even a grad student, so basically post the equivalent of a bachelor, other students would ask me when they entered the field and I was a tutor, where can I do AI here? Who was offering real AI classes, even though we had a very large and active AI department in our university. And so I decided that I had to offer AI classes, right? So as a student, I started doing a seminar on building cognitive architectures and on thinking about the mind. And so I got a dozen students who started building things with me. And this is the origin of the microsci architecture, by the way. This is how I got into working in academia as a student.
Ah, that's a very interesting story. You sort of reacted against the prevailing trends in academia, where, as you said earlier, unfortunately, the funding and promotional carrots, rewards are focused on, relatively small incremental steps against, known benchmarks. You raise the benchmark by 0.5% and you have a paper you can publish. Publish 7 papers, you get tenure, right? And that's not the grand question of how do we make a machine that thinks sort of like a human. Are you still optimistic that we can create computer intelligences that are at human level and beyond?
Of course, there is no obvious reason why we shouldn't. There's nothing magic going on as far as we know in the brain. I also don't think that there are, and this might be very controversial to some, deep, open philosophical questions left that have to be answered. What needs to be answered is a lot of technical details. And for a lot of these details, I think doors have opened to work on them in the last few years. So even though I don't know how long it's going to take and whether it's going to happen in our lifetime, I think there's a significant probability that we will see something that is not human-like, but in many areas superhuman-like, and in other areas good enough-like within our lifetime, or maybe even in the next few years.
Yeah, it's hard to say. It's one of these damn questions. It could be 5 years, it could be 100 years or more, right? And of course, it also, as you say, depends on where you're measuring. If you talk about every single facility, it might be 100 years. But if we're talking about superhuman capability in certain domains, that could happen, or frankly already has happened in narrow domains, like image recognition under certain very constrained cases. And those windows will open larger and larger. And I will also say that one of the things that's made me more optimistic about superhuman capacity across the board is the more I've learned about cognitive science and cognitive neuroscience, frankly, how limited the human brain is. Things like working memory size, fidelity of memory, et cetera. We're not that smart compared to what we could be. Working memory alone is a huge bottleneck on, for instance, the practical level of recursion in language and chunking size of concepts, et cetera. The low fidelity of our memory and the lack of persistence is certainly a major cognitive limitation. So I'm not one of those people who thinks that the humans are the top of the intelligence spectrum. Frankly, I believe we're approximately the stupidest possible general intelligence, which is not surprising. Evolution is seldom profligate with its gifts. And since we're over the line of general intelligence, or at least so it appears, we're probably just over the line. And so I'm one of those who is also very hopeful that we can get not just over the line, but way over the line, at least in some very interesting dimensions, such as language understanding, the ability to read the literature of a discipline and actually make sense of it, et cetera.
I remember that I've always been very disappointed in the capacity of my brain as a child and later on. And I also felt bad about this because at the same time I was confronted with the superstitious belief of most people that if you apply yourself, there is basically no limit to what the brain can do, right? We could have maybe infinite memory. Maybe if we would just pay attention all the time, we could read all the books and retain all the books. We could retain all the movie. Maybe we could have photographic memory for everything. Maybe there is no limit to our intelligence if we really apply ourselves and meditate enough, right? And later occurred to me that this is probably not the case. I do know many people that are much, much smarter than myself and know much more than myself, but it's often at the expense of other things. So it means that they tend to have a much narrower view on things and know these things much, much more deeply and apply their attention to exclusively these things and not to others. Of course, there are some people which are way smarter than me across the board, and I'm totally in awe of them. But still, it's just a shoddy human brain. And this shoddy human brain, I still don't know how much compute we need and how much ingenuity we need to replicate this shoddiness, of course, right? So even though we can see the limits of what it's doing, to get this to run, it might be possible that it's doable with something that you can, as an average person, already buy and put into your basement if you really want to. So something in the order of, say, 20K of compute. Maybe that's possible. And I'm optimistic enough to say that there is a chance that this is the case.
Yeah, it's interesting. I've had numerous discussions with our mutual friend, Ben Goertzel, about that, right? And, I think we both have come to the view that I think it will turn out to be what is the appropriate level of representation. My home academic discipline is evolutionary computing. And in evolutionary computing, again and again and again, it turns out to be what is the representation on whether a technique will provide traction on a problem. And so if it turns out that the actual right level of representation is indeed the neuron, then probably 20K computers won't do it. If it's symbolic, truly symbolic in the old-fashioned AI sense, then probably, 10 computers, call it $5,000 worth, will be enough. But as I suspect, if it's some hybrid between the two and kind of messy and has some very low-level stuff and some very high-level stuff and some transducers between them, it may be on the order, this is my best guess, and I think Ben thinks my number is high, but he agrees that it's a plausible ceiling, essentially the equivalent of 1,000 powerful desktop computers. So we're talking on the order of $1 million of hardware today, if we got the right level of representation at it. And of course, $1 million worth of hardware is no barrier at all to produce something as valuable as human-level artificial intelligence.
If we look at a thing like, for instance, GPT-2 or 3, the models that OpenAI has recently been working on and publishing, what goes into these models is relatively moderate cost that still will drive academic researchers sweat on their forehead, but it's something like $2-digit million that go into training these models. And they are trained on a few years of almost a full take of the internet that has been filtered down to something that removes most of the most obvious crap. And then it's very basic. The common crawl is a large part of what you find in text that's written in a given year on the internet. And then it is able to go through this enormous amount of text that is like a very, very large library. There's lots of babbling inside, and extract all the meaningful correlations, or a significant part of the meaningful correlations from it in relatively short time. Right? It's a task that is way beyond what a large group of researchers could do in their lifetime. And it's done in the course of a few days or weeks, these computers. And that is a tremendous achievement that you can do, right? And if you imagine you would have something that is only able to process these data at a human level across all modalities, maybe you transmogrify the data so you get it with the highest bandwidth possible in a nervous system that has a capacity similar to ours. That would be a tremendous achievement if so much data could be processed and extracted in such a short amount of time. And I don't mean that GPT-2 or 3 are human-like. For me, the fascinating thing is that they get so far that you have a relatively simple algorithm. You can produce embeddings over text, and as they've recently shown, images that allow you to make continuations of the text and the images that are basically surviving a type of Turing test, where the audience is unable to tell better than chance whether the text that they're looking at has been written by a human, or whether the image that they're looking at has been generated by a photograph, even though it's a low resolution image.
Yeah, that is interesting. I mean, as you say, this is not the way humans do it at all. And I had looked quite a bit at GPT-2. I haven't looked at GPT-3 yet. And I did some experiments, et cetera. And it wouldn't have fooled me for very long, but apparently could fool some people. But it's essentially, an extraordinarily deep pattern matching system. And is that all human language understanding is? I don't know. It seems to me that there's something missing in these brute force deep learning approaches when it comes particularly to language. That, yes, it's amazing what they'll do. The translation algorithms that Google famously developed, GPT-2 and presumably GPT-3 and GPT-4 someday, may well be able to fool us. But do they actually understand language at the level of, say, for instance, reading every paper and every textbook in cognitive science and actually then being able to make some inferences about what's missing in cognitive science and what new theories or experiments are needed? I mean, that's the kind of thing a human could do. Not very well yet, but that's what, a professional cognitive scientist does. Could GPT-4 do that? I don't think so.
The thing is that GPT-2 and 3 are not sentient, apparently, right? So they have no model of a connected, unified universe. onto which they match everything that happens in real time, and they understand their own role in it and so on. It's not that they are far from it. It's just that it's not part of their task. They haven't been asked to do that. This model has not been trained to do such a thing. And yet the capacity that this thing has is tremendous. And there's, while a lot of people will say, oh, this is not grounded and has no connection to reality. The question is, imagine that all you would have as access to the world is your own imagination, the mental space in which you can produce mental simulations, and lots of books and a way to parse them. And at some point, you basically try to hash out the space of possibilities in which all these symbols that you're confronting can possibly make sense and give rise to a universe that contains you. Is this something where you can prove a priori that this is impossible, that something like GPT-2 or 3, a simple text processor, cannot hash it out based just on the finding one of the possible orders in the patterns after noticing there are not that many? And once it figured out the relationship between concepts in some kind of relational space that is dynamic and produces an evolving world, can they start parsing the Wikipedia articles on physics and all the papers on physics that they read and understand possible solutions to the big puzzles in physics and so on that allow us to understand the automata from which our world is generated? I don't know that. GPT-3 seems to be an incremental extension over GPT-2, so basically uses magnitudes more data. And the learning curves are not bending yet, so it seems that you can extend this even further. And the quality of text that GPT-3 is producing in terms of coherence, so the illusion that what it writes corresponds to a self-coherent universe where concepts are consistent for at least the duration of the story, this is much better than GPT-2. So in GPT-2, you could easily see when its construction fell apart, when it lost coherence. And this is when the story becomes unbelievable, right? You're willing to entertain a completely fictional story about a completely fictional universe as long as it refers to a coherent universe. It might be a fantastic universe, one that doesn't make sense, but it's one that works by certain rules. Like if you take Buffy the Vampire Slayer as a fictional universe, it's a universe where everything is normal for a sanitized version of normal. It's a suburbia that doesn't really exist because it's so perfect and stereotypical. And the only thing that's different from this perfect and normal and stereotypical world is that every year 20% of the population dies because of an invasion of vampires. And everybody goes on with their life. And this is probably not realistic, right? We know what happens if 1% of the population dies in every given year through COVID. Everything comes to a halt. And so this is a universe that is only meant to highlight things in the stereotypes and the normal interactions by introducing this new element and deliberately leaving everything else that would be downstream from this unchanged. And this is an interesting construction that our mind can make. It's producing a universe that is derived from our standard universe with all the right constraints. And it's referring to this global meaning, and that it deliberately only changes very few things while leaving the rest alone. And the people who understand this understand these layers of meaning that exist. And this would be an interesting benchmark to see how many layers of meaning can GPT-3 distinguish and construct versus GPT-2. With respect to the complexity of a brain, I think it's possible that the unit is not the neuron, but that it's the column. It might be that this is a simplification and the actual units are somewhat orthogonal to both neurons and columns. So in some sense, you have units that are made from columns, you have some that are made from multiple columns and a couple neurons, and you have some where the neuron and the column and the couple neurons interact in a specific way. Or you could have processes inside of the neuron that play an important role that you need to understand in order to model the behavior of that thing. It's similar to understanding the role of people in society. But at a certain level of granularity, you don't have people, you just have organizations. And yet, to understand the interplay of the organization, sometimes you need to look at individual people that played a role in historical developments. And to understand the behavior of these people, sometimes you need to look into very particular things in their own mind that happened in a certain moment in history. And without that, you cannot understand it. So this simple granularity that we put on the model is often too coarse to make it happen. But if we just entertain the idea that columns might be the thing, because they are somewhat ubiquitous over the neocortex. They are interchangeable. You can basically cut out non-specialized columns from the brain of an infant mouse and transplant them to another area of the brain. And when they will adapt to fulfilling the role of that part of the cortex. So the columns seem to be pretty general as far as we know right now. And a column is something like 300 to 400 neurons. So we end up with something like in the order of 100 million units. And if you imagine we have, give or take, 50 brain areas, it would mean that each of these brain areas has in the order of 1 million units. And the units can do way more than an individual neuron can do. And even an individual neuron would probably need a 3-layer network to model it as a perceptron. But eventually what they do is that each of them can link up potentially with a few thousand other units. And these few thousand other units are not what they're linked up permanently. It's the address space. It's what they can talk to. And each of them has a number of states that they can have and dynamics that they can undergo, set of functions they can model, and it's limited what they can do, right? And so if you imagine that you could understand that each column is something like an adaptive agent that is doing local reinforcement learning by some policy and is wired up into a global architecture with the others, then maybe this does fit on a few larger GPUs already in real time.
Yep, that could be. Now, I want to clarify something that in my readings in your book and your talks and papers, you talk about 100 million columns. As I recall from my reading, and I actually did look it up this afternoon, there's probably more like 100 million mini columns and 1 million columns. Columns seem to be made from multiple mini columns. Which one are you talking about when you're...
I was talking about mini columns. And the formation of columns is also different in different brains. So for instance, if you look at a mouse brain, you will find that a large part of the neocortex seems to model the activity of whiskers.
Okay, yeah, makes sense.
And so the input space of whiskers. And the columns form together into macro columns in a way, which are almost like regions. And it's not like you could look in the brain and you see very clear-cut cells that are, it's just that you have groups of neurons that have more interconnectivity among each other, and you lump them together in a column. And you also find that they coincide usually with the glia cell around which they're formed. But it's not by any means a very, very clear-cut architecture. It seems to be possible that neighboring columns that fuse and perform functions together and so on under certain circumstances. So it's a lot more messy, I think, when we look into this in detail.
So you look at the mini column as the closest thing to a reasonably generic unit. Okay, that's good.
Yes, but it's really something where I'm already squinting a lot and possibly too much. Another thing that I wanted to put on my mental stack when you mentioned it is the question of whether we are just the least intelligent thing that is generally intelligent in nature. And so I wonder is why there is nothing that is obviously smarter than us in nature. Because even for a monkey, it's hard to have a brain that is larger than ours. There are brains in nature that are larger than ours, right? Whales have larger brains. Elephants have larger brains. Why is it that whales and elephants are not smarter than us? Because they basically carry these brains around for free, right? They have so large bodies that they scaled up the brain with the body size. And it's not that they need a proportionally larger cortex to control a proportionally larger muscle. That is true for the body map, but only a very small part of the brain is your somatosensory cortex. So what do they do with all this extra capacity? Why is it that they are not that smart? And I suspect that if you make a system too smart, it's very hard to control it. It could be that elephants have massive autism, because if the non-autistic elephants meditated themselves out of existence, they basically started to understand their role in the universe like very smart monks. And then as a result, they decided that doing office politics all day and having kids and participating in society is just not cutting it. And instead, they just go to do something more interesting with their lives, like meditating. And these elephants didn't have a lot of offspring. Who knows if that is the question? So I wonder if this...
That's a crazy idea. I like
right?
that.
It is a very crazy idea.
That's weird. I like that. I'm going to lay that one on somebody and say, oh yeah, we only have autistic elephants because elephants would otherwise be so smart that they would, be too busy philosophizing to reproduce.
I mean, with the dolphins, it's obviously slightly different. That dolphins, they live underwater, and you cannot really hold a pen underwater because everything you write down will be washed out. So there will be no life for intellectuals because they cannot read and write underwater. So the dolphins all only talk about sports and celebrities and sex, and their society is not moving anywhere.
And they have 3 dimensions too. That's another thing. It requires a better brain to operate in 3 dimensions at the speeds they operate at, right?
But navigation is so much easier, right? Because you don't have to solve all these knot puzzles. You can just move where you want to.
Yeah, and collisions are much less likely, right? When you're stuck in 2 dimensions, collisions are constantly on our mind. 3 dimensions, it's easier to dodge, right?
Yes, you'll probably also notice that self-driving airplanes are completely common and standard for many, many decades now, while self-driving cars are difficult.
Yep, that's a good point.
Because the navigation that you need to do on the ground to coordinate with all the other things that are limited to 2 dimensions and have so many crossing paths are just harder.
Yep, I love that. Yes, where geometry and cognition come together, and that's exactly the right answer. Let's jump back a little bit to a point you passed over rapidly, but I would love to dig into a little bit, which is your statement that, in your belief, the philosophical questions are sufficiently answered to proceed. What is your take on the nature of the mind? Are you a strict materialist?
I suspect that there is a misunderstanding with respect to what matter means. I found that a lot of people think that matter is immediately given somehow, that we have seen atoms and touched them and the molecules and the earth on which we stand and the air through which we move. And while this is experientially the case for the earth and the air, it's not so quite true for the atoms and the underlying structure, right? And when we look at this in more detail, it just turns out that what we mean by matter is a way to talk about information. And what we specifically talk about is the way that we can measure change. And we notice that we can measure changes, periodic changes in place, which we call matter, and we can see how these periodic changes in place move between places, across locations, and this is what we call momentum. And the description of the universe in terms of matter and momentum is what we call physics, right? So physics is the set of functions that describes how adjacent states of the universe are correlated. And the idea of physics is that we explore the hypothesis that there is a causally closed lowest layer in the whole thing. This is what foundational physics is about. What's the causally closed lowest layer that describes this entire universe that we are in? And this hypothesis that this layer exists and it's discoverable to a large degree and can be described or inferred is a very successful hypothesis. And this hypothesis doesn't have a really good contender. There is not another game in town that is quite plausible. And what would that other game look like? And typically we confront it with the notion of idealism. So instead of matter being primary and matter being the way information travels in something like a mathematical space, so set of discernible locations and trajectories that the information can take between those locations, we think that the mind is possibly primary. So the conscious experience is primary. And subjectively, that's true, right? The consciously experience is affecting a now that we have given here in this moment. And this now is not the same thing as any particular physical now. The physical universe is smeared out and uncertain with respect to that. It has a very vague and weird relationship to this experiential now that is immediately given. And if we make the step to say that this experiential now is everything where something can be real and experience is real by any observer. In the physical universe, there's nothing out there that can experience something, that can be confronted with a reality, because in physics, there's just automata, only unfeeling mechanisms. Everything that is real is in a dream. It's in here with us, in this thing that we perceive that has colors and sounds and feelings and so on, right? So if we make that thing primary, there still needs to be an outside that dreams us. What is the thing that dreams us, that produces the dream that we are part of? The dream in which physics takes place from our perspective, in which where we construct our ideas of physics and everything else. And that thing out there, this outside world that we cannot access, this is still physics. If we are dreamt by a mind on a higher plane of existence, then it turns out that this higher plane of existence is still the skull of a primate with a brain inside of it. And that higher plane of existence can be modeled with the ideas of physics. It's not changing anything.
Yeah, but is that necessary? Or when we talk about, let's say, human minds emerging from brains, I'm kind of a naive realist myself. Maybe I'm too naive, but I think there is a physics out there, and physics emerges to chemistry, and chemistry is very stable and predictable, and from chemistry, we get biochemistry, and from biochemistry, we get biology, and from biology, we eventually get neurons, and then neurons, we eventually get nervous systems, eventually, we get brains, and at some point, probably around the time of the reptiles, or maybe the amphibians, we finally got mind, which is the subjective state. Then mind is a new subjective state that is packaged within physics. I think that's the alternative way of looking at it.
I suspect that you don't need to tell the story from this direction. You can spend hundreds of years sitting in your monasteries in Tibet or wherever and be super smart and have all the time in the world of your hands because you convince the local peasantry to give you free breakfast every morning because you're a holy man. And you sit together with other smart holy men and you write books and discuss psychology introspectively at a level that Western psychology still doesn't quite master. And you do understand many parts of the mind and how they interact and so on. And you never, ever venture out to describe physics for some reason, right? It's not necessary to do so because you do not intend to revolutionize your society and invent new means of production, make everything more efficient, because that would probably destabilize society. So you leave that as it is, and society outside is something like a periodic process that you try to organize as well as you can. So it's somewhat stable, but you don't want to turn it into a runaway process with technological progress. So why would you want to look into physics? You don't need to do that, right? So many cultures only focused on this mental perspective and the inner structure of perception first, and not at the outer structure that enables it. But if you're not looking into physics from our perspective, you are leaving money on the table. If you ignore this entire scope of models that work out, that do have predictive power, tremendous predictive power, that allow you to build machinery that all these other civilizations could not build and even think and reason about, and did not even start to consider possible, because it was nothing that they based any ideas on what you can do in the mechanical universe. It's possible to do that, to leave all that on the table. And our culture is a little bit weird because our civilization is not that old. I think it just started 400 years ago. And we are mostly unaware of that civilizational break that we had when we got out of the cults. And the Catholic civilization is one that obfuscated the area of the mind because it made it all part of a mythology. So you didn't have the free space to reason about psychology within the Catholic society. All this was taken up by gods interfering with the selves on the same brain. People were, in some sense, discouraged to study psychology because it might interfere with religion. And the physics that they engaged in was also somewhat crude because access to rationality needed to use certificates that you would not accidentally disprove religion, interfere with it, because it was, in some sense, an anti-rationalist system that people had to live in. And what we did was we freed our rationality for the first time in thousands of years. And this new rational society that woke up with the Enlightenment dismissed all the stories about the mind that the Christians had ever told them and thought of them as superstition. So we lost many concepts, and we are still in the process of restoring them. For instance, I'm fond of saying that spirit is a word that we have dismissed now as superstitious, and it's an old word that just means operating system for an autonomous robot. And when the word was coined, it just meant that the autonomous robots that existed. So there were people, there were plants, animals, cities, nation states even, possibly ecosystems. But this was it. There were no robots that people had built. And now that we have autonomous robots and they have operating systems, we understand that there is something like an operating system and that humans must have one too, and plants must have one as well. And obviously societies and civilizations have some kind of operating system, right? And we understand that this operating system of society is not real. It's virtual. It exists over the coherent interactions of individuals in society in the same sense as the mind does not exist as a physical thing. It exists over the coherent interactions of the neurons or whatever are the constituting parts are.
Yeah. Oh, and I think that's a very important distinction. And, in my study of complexity science, the way I will often say that is reductionist science, let's call it old style science, is about the dancers, while complexity perspective is about the dance and the dancers, right? So the things that hold together, let's say a business company, they're virtual, they're abstract, you can't put your finger on a particle and say this is the operating system of a business, and yet the business is real. It is a series of coordinated actions operating on signals with boundaries and semi-permeable membranes. It has feedback loops. I think that's key, and you make that point as well in some of your writings, that feedback loops are absolutely critical in creating higher levels of complexity in systems, at least they appear to be. For instance, in one of my critiques of our current operating system is that our current society level operating system is overly driven around the money on money return loop. Everything is in the business world, and frankly, in many people's personal world, is all about optimizing money on money return. And that has produced many of the less than desirable characteristics of our era. But that is a real thing. The flow of money is an information processing modality, which ends up coordinating behavior of actual atoms. And we get down to the emergencists' argument about what is top-down causality. But one could argue that a society organized around money on money return has top-down causality, and that it requires, Mary and Joe to get up at 7 o'clock in the morning, drive for an hour, and work in a bullshit job for 8 hours, and drive an hour home again. So I think this broader concept of, what is real, to include, complex adaptive systems, gets around this false distinction between dead matter and live systems.
The notion of the feedback loop is very old. I suspect that every statecraft that built societies deliberately had to have this notion of feedback regulation in it. And the understanding of nature, you find this already in Aristotle and in our intellectual traditions. Throughout the times, this notion of the feedback loop, you find it in La Mettrie, where he describes that there must be systems of competing springs in the mind that pull and push against each other and keep it in some dynamic balance. And so it's a very classical notion, and it became the core of cybernetics and control theory, and was a very popular paradigm for a very long time. But I also suspect that there is this little bit of traditional superstition around the first and second generation of dynamical systems theory, especially second-order cybernetics, in the sense that we are tempted to think of these dynamical systems as real. And I suspect that they are just models. They're not real. They are the behavior of too many parts to count in the limit. When we describe how individual things interact, we can often track them and see the low-level processes that change the evolution of one system across the boundary of by another. And if we can no longer do that because you're looking at trillions of molecules, for instance, you will have to resort to models that look at the statistical dynamics of these too many parts to count. And some of the resulting mathematics have convergent results, and others have not. And the geometry of the world that we're looking at when we look at dynamical systems, this is typically the stuff that is convergent, where we can make models. And so it turns out that Newtonian mechanics is these convergent dynamics of too many parts to count within certain ranges. It's not real because you cannot really make Newtonian mechanics perfectly working from individual parts. It's only within a certain region of many parts, too many parts to count, that you get something that looks a lot like Newtonian mechanics. And for a different region, it's true for Einsteinian mechanics, right? But these systems are not real. It's just a level of the modeling that gives you coherence. So when you are an observer and you zoom into the universe that contains you and the many parts that make up yourself, you basically will often find layers of description where you can make a coherent model. And these are the ones that we latch on as description layers. And then we discover that they form a hierarchy. And then we try to establish causal relationships between them. But these causal relationships are not causal relationships that exist in the physical universe. Causality is a model category. It's a property of the models that we are making. So when we talk about these big conundrums like the mind-body problem, we're not talking about how is one physical set of things, like bodies, connected to one other possibly non-physical set of things, minds. what we have to talk about is we have here one category of model that is our body map that is dynamically arranged in space and articulated with skeletal muscles. And on the other hand, you have mental states and mental processes and software states and so on. And these two disparate categories of models, how can we make them congruent?
Well, they obviously have to operate together. I was going to give an example about what does reality and models really mean. We talked earlier about companies, right? That they're virtual. You can't really put your finger on saying that's the company, right? It's a standing wave, essentially, of action and motion. But they're real in the sense that they have traction in the physical world. And that's, I think, a reasonable assessment of what is real. And as an example, think of a coal mining company, a company that digs coal out of the ground. So in terms of traction in the real world, they dig holes and they deliver coal to people who turn it into energy. So there are actual things that are done in the world by this virtual thing called the coal mining company. And obviously trying to track that at the level of atoms would be ridiculous. And even tracking it at the level of human beings would be exceedingly difficult, and would, maybe if you had billions of dollars, you could simulate a coal mining company at the level of individual humans. But interestingly, at the level of abstraction of accounting, it's quite simple, right? And people make large bets based on the future of one coal mining company versus another, based on the signal, very abstract, very high level of accounting information that comes out. And the result is company A gets smaller and company B gets bigger based on people's assessments of this high-level information. And yet, at the end of the day, we have to say that the mining company is real because it is having very significant impact on the real world.
Well, not everything that has a significant impact on the real world is real in a particular sense, right? So you could say that ideas have a significant impact on the real world. And it's very often difficult to say what the idea actually is because it only exists approximately across minds, right? So if you think about a political movement, how would you say that the political movement itself is real if the idea behind the political movement is understood by most people in different ways? But for a company, it's much, much easier because we have a software, our legal system, that defines the conditions under which a company exists. Right. And so you have a criterion by which you can decide whether the company is there or not and what state it is in. But this is because we have created a substrate for the company to run in. It's similar to what happens in our computers. We have built a deterministic system with clear rules that allow us to decide whether a bit is set in a gate or not, or in a register or not. And this allows us to construct extremely precise models of the behavior in the computer and preordain the behavior of the computer. It's a very specific thing that is probably different from minds where the state that the mind is in is still somewhat probabilistic.
Yes, I would say that is true. But it also seems to be, at least in many cases in nature, that emergences to higher level structural entities are built from relatively well-defined lower level units. And when you lack those more defined lower level units, it appears to be more difficult to get emergent properties to come into being. So, for instance, you make the good point that the fact that our laws are relatively uniform and they result in currency that has equal value, and that people can only be exploited so far because of the limits of the law. So at some level, they're almost fungible, may actually be part of the mechanism that facilitates the emergence of the mining company. Perhaps in the same way that the fact that neurons, while of course they vary, and there's at least 100 different varieties, are not that different compared to non-neurons, right? They are relatively fungible units of construction, and they give evolution something to work with to produce higher level emergences, in this case, mind. And we can take mind to be not just human minds, but minds all the way down to wherever minds first come into being on our evolutionary tree. And so I think that's an interesting and important thought, that we typically have a level of emergence that has relative simplicity at the outer envelope of the component pieces at that level, and that those combining allow us to reach the next level of emergence.
But we also know that the rules that are implemented in the world that are so uniform and so on, for instance, the financial system needs to be, in order to work, to be implemented in a way that is rather uniform, where you don't have large opportunities for arbitrage, right? Where you have leaky abstractions. And yet we both know people that got extremely wealthy by specifically looking for the fine print.
Absolutely. And then no systems are perfect, right? Biology is subject to attack by viruses, for instance, right? A virus is not actually a biological entity. It's essentially a flaw in biological systems that they're exploited by dead chemistry, in the same sense that arbitrageurs are essentially like a virus operating on business, looking for the flaws in the system, and there will always be them.
So the two interesting questions. One is how much fine print is there in the mind? So to which degree does the mind not emerge over the activity of neurons, for instance? To which degree is this a simplification? And to which degree is it a very good abstraction and should guide all of our thinking and not? And there are some people which feel that the neurons are not the right description at all and might have even superstition connected to that. But I think it's still worth keeping that in the back of the mind, so that there is usually some degree of fine print involved when we make such models and circumstances under which this is not the entire truth and more interesting things are going on. With respect to viruses, right, the coronavirus is not a life form. It's more like a text that the cell cannot help itself not to read. And when the cell reads this text, it's doomed, because it cannot sandbox the idea that is contained in the text. It will have to turn it into an action. And these viruses exist also in society in a way, right? But it's not as if the cell or the biological life ever existed for a long time, at least, without these viruses. These viruses have been around briefly after cells came into being, probably. So the cells already contain a lot of viruses. All the existing cells are the result of many, many interactions that they had with viruses, many of which permanently migrated into the cells that later on divided and became us, right? So the same thing is true for societies. A lot of the ideas that we have are the result of the interaction with viruses that interacted with the pure host ideas that had been formed in a natural convergence rather than being an infection process that interacted with the natural convergent state of a virgin mind and then took roots in there and formed an immune system to make sure that competing ideas don't take root in the same mind and so on.
Exactly. I've often used the term memetic viruses for, radical ideas that challenge the status quo. For instance, the scientific revolution of, starting around 1700 and probably reaching its pinnacle, at least with respect to the Christian thing that came before with Darwin, were some very virulent memetic viruses that were brought out by individual thinkers and collectives of thinkers. And they put a substantial hit on the pre-existing status quo model of the universe. So I think, that concept of virus more broadly constrained makes a lot of sense.
Mm-hmm. There's, of course, the question whether the virus increases the fitness of the individual and the group. And it seems to be quite obvious that if you look at society, that the viral evolution, the memetic evolution, does not necessarily have to lead to improvements.
Nor does the biological ones don't either, right?
In the long run, I think that the things that don't work out are going to be removed from the playing field. This is how evolution works. But it can be a temporary breakdown of complexity that you observe. So it could be, for instance, that you have a species that spreads over a very large area of your ecosystem and is very homogeneous, and this makes it very susceptible to an infection. And then the entire population gets, or a large part of the population gets wiped out by a relatively simple attack vector. And if you have more diversity across species, you have more resilience against viruses. And the same thing can happen in a society. So everybody is using the same kind of social media and the same news sources, then society can have very homogeneous virus infections. And as long as the virus is adaptive in the sense that it makes the group coordinate better, it can even convey an evolutionary advantage on the group and make the group outcompete other groups. So I wonder to which degree we are the result of such a viral domestication process, that we basically are living in a civilization that has outcompeted other civilizations because people in it were very susceptible to this same mind viruses. And as long as the viruses were accompanied with some kind of church and an immune system like an inquisition that would make sure that everybody would be susceptible to the same viruses and not rogue viruses, right? The society is possibly more successful than other societies. And then if you remove the church and you have all these superstitious people without individual epistemology and any kind of firewall against rogue ideas that have no chance of being true when seen at it with bright eyes, that this might create a dangerous situation where your society just falls apart because it splinters off into random cults.
Yeah, we're running that experiment right now, right?
Possible. It's also possible that everybody just suddenly seeing the light at the same time, right? And this amazing thing happens that after several thousand years of human evolution, we suddenly got to the point where we have the right moral opinion about everything that we didn't have in the 1500s or in the 1800s or in the 1950s or the 1970s or 1990s. Now we see it.
Of course, everybody thinks that. They always think that they're right. Every epoch thinks that they're right. But I do think that one of the experiment that we're running of memetic viruses everywhere and eliminating many of the quality control mechanisms that more autocratic regimes have may destroy us or may take us in a phase change to the new level. And that's, what some friends of mine, myself, are working on is, can we get to a new level of civilization? Well, not all of our answers will be the right ones, but there'll be a lot more right than the status quo, in particular, learning how to operate within the limits of our ecosystem. The current status quo seems to have no brakes on it. It does not know how to stop. It keeps producing new things, whether they're actually good for us or not. And indeed, many of them are dangerous to the continued existence of the human race. Think nuclear weapons. Just finished reading this weekend a very interesting book by William Perry and another fella reminding us there are still way too many nuclear weapons out there. And if there should be just a mistake, it could knock us back to the Stone Age quite easily, right? Let alone things like CRISPR or AI risk, et cetera, which we'll talk about in a little bit. So anyway, that's interesting. But let's move back to our topic a little bit here. And let's go all the way back in time, in fact, before modernism really got started, right at the cusp, with René Descartes and dualism. Dualism seems to be a strong attractor to this very day, right? And a place against that, a view of, talking about consciousness here, essentially, or the mind or the spirit or whatever we want to call it. Descartes, of course, famously believed it was of a different substance than the body or energy or signals. It was, literally something very unclear on how it interacted with the physical universe, but it was of different substance. While someone like John Searle, who I have found to be one of the more interesting philosophers of consciousness, argues that no, consciousness or mind more broadly is nothing but an emergent system from biology, very much like digestion. And like digestion, it comes at a high energetic and a high genetic cost to keep it going. And, those two seem to be the poles of our historical thinking. And yet Descartesian dualism still seems with us.
I wonder to which degree the generation after Descartes has basically simplified his thinking. And that is especially apparent when you look at occasionalism, the question of how the spheres interact. How is it possible that the mental sphere and the physical sphere can interact when the physical sphere is causally closed? Right? It's if the mental sphere doesn't need to be causally closed, it's possible that something is getting into your dream and messing with it. But how is the dream world interacting with the physical world if the physical world doesn't need any kind of external interaction to go with it? And there must be a reason why Descartes didn't see this as a very big problem. Also, what I find is when I read his texts, he is often smarter than people give him credit for. For instance, in the Meditations, he will interact with religion in the same way as somebody, say, in communism might interact with the political dogma. That is, he will make a nod to it and pretend to see no reason to doubt it, but will defend it with implausibly weak arguments. So that everybody who is able to get to a certain point in their own thinking realize this is not an argument that is good enough to actually make a point that this person is highly incentivized to make. Then you only need to make the next step and understand, oh, maybe Descartes was smart enough to understand this as well, and smart enough to understand that I would possibly be smart enough as well to understand this. So we got this out of the way and understand why he wrote it, right? There is a reading of Descartes that is relatively straightforward, and that is that both substances are mental substances in a way. So res extensa is the thing that, for instance, Jeff Hawkins' Numenta is so obsessed with, this idea that everything that happens in the mind is in some sense a representation that maps to a certain region in the same three-dimensional space. The same three space is here a model, right? It's the space that our mind models about the universe. And this interpretation of Jeff Hawkins is not complete because our mind also has a lot of content that does not refer to anything in the same moving three space. So if you would say these two categories of mental thought, the physics engine that our brain is generating to deal with predicting sensory data across all modalities, and all modalities will be mapped on that physics engine, right? Everything that you hear and see and touch is mapped onto the same three space. And all the other things, this would be your res cogitans. This is not res extensa. So just say res extensa is the physics engine that your mind is generating. Res cogitans is everything else. And now you can easily see how they interact. Both are software.
Yeah. I want to hop back to a comment you made earlier about the mind not being causally closed. Do we know that? Is it possible the mind is causally closed? It's just very complex.
The question is what kind of causation you observe in the world. And this was an idea that first occurred to me when I was a kid and was playing on Telnet. There was a class of computer games which were called MUDs. They still exist in a way, but most of them are now graphical, multi-user dungeon adventures. And many of them were implemented in an object-oriented language that allowed you to create an arbitrary world from text. And so it was very much like a text adventure, but it was a text adventure that was dynamically evolving and in which people could interact across many computers. So they would log into the same server and each of them would have a virtual character and avatar that would play in that world. And some of the people advanced to the point where they would become wizards and even gods. And a wizard, a magician, is somebody who has right access to the rules of reality. Somebody who cannot just use the surface layer of reality that is producing a certain mechanical structure, a certain substrate, but you can go on the substrate beneath that. And the substrate beneath that change the rules by which everybody else has to play, right? This is what magic is about. And it's also what magic is in the real world about. A witch is somebody who focuses on the way in which other people construct reality and messes directly with that layer. So the people around the witch will have a reality that is open to the attacks by witchcraft, by the right access to the attention of people, to the way that people perceive their own relationship to reality and to the witch. That was the reason why the witches have met the similar fate under the expansion of Christianity as the Jews did under the expansion of fascism. It's basically a competing system of seeing the world that the dominant new vector did not seem to be compatible with its own mode. So it tried to eradicate it. So witchcraft in these games existed, right? It's a way to make people perceive reality different by changing the rules by which people have to perceive reality and interact with it. And this witchcraft exists in our mind. There are ways in which we can perceive miracles and make other people perceive miracles. And it comes down to creating a mental entity that you can control in the mind of another person that is changing the other person's memories and perceptions. And as soon as you notice that you can edit your own memories and you catch yourself editing your own memories, you notice that the interaction, the causality in your mind is symbolic. There is stuff going on like you perform a certain ritual that involves maybe sacrificing a black cat. And as a result, things in the real world change that are not obviously mechanically connected to the sacrifice of the black cat, right? It's a completely symbolic interaction. The power of symbolic rituals can only be explained, I think, by the fact that our minds are not the causally closed lowest layer.
So you're saying that sacrificing the black cat actually does cause a change in physical reality?
No, it must cause a change in the way that you make sense of physical reality, in the way in which you relate to physical reality. The model that you make and the actions that you perform as a result of that change, you regulate in a different way. And as a result, reality will now look different to you.
That certainly makes sense.
So for instance, you could make a ritual to become, say, a CEO of a company. Imagine you are a person that is an employee of companies, difficulty to hold on to a job, they're financially struggling and so on. They really don't know what to do about this. And there is no way they can get out of this. They look into all the rules of reality that exist, and they can look into economics theory, and they realize I'm a member of the working class. I'm fucked. There's nothing I can do about this, right? And then they meet a magician, and the magician says, look, we can do these rituals. And there are a lot of people that offer this magic as a service. They have this abundance meditation and expensive retreats and so on. And they basically reprogram you into becoming, say, a glorified parasite or an entrepreneur or an investor. And the difference between an investor is not some magical ritual that has to be performed at birth, or a change in the universe, or a change in the social order. It's a change in how you relate to the world around you. If you can basically change your expectations in such a way that you consider yourself to be a very different system, you can often gravitate to a very different place in society and in the economic order, right? And suddenly you have this big house and this big car. And it's not that you are working necessarily longer hours than you did before, but you just interact with the outside world in a completely different way.
You've updated your code. I mean, it happens all the time.
And the same thing happens, say, with relationships. Say you want to find the perfect partner, or you want to meet very particular people, and you perform a certain ritual, and that suddenly changes the way you interact with reality. And as downstream effects, also makes other people interact with you in a different way. And suddenly you find yourself in a very different position in the world.
Yep, that's true, but I'm not sure about its significance. If we assume that something like a rough distinction between hardware and software, and I understand that there's actually many layers of software in the mind, to update your code and then therefore have a different degree of traction in the world than you did before doesn't strike me as particularly mysterious.
You know, if there is only one real layer, and it's the layer below quantum mechanics, and everything above that is models, there is a lot of ways in which we can meddle with these models to get the outcome that we want.
But so far, we have not found any such mechanisms to actually impact the level of physics. Right? We cannot change the mass of electrons via witchcraft. We cannot change the spectral characteristics of Alpha Centauri by sacrificing a black cat.
Exactly. So there seems to be a level at which reality is causally closed, at which magic is not possible. This was the point that I was trying to make, this hypothesis that the world is entirely subject to symbolical magic falls apart at some point, because there seems to be a layer outside of our minds that we cannot change, where the rules do not change. And the question between the magicians, between the people that think that everything is a dream, is whether this is only because we have agreed with each other that there are certain parts of the dream are immutable. And we cannot defect from that dream, because then we will go insane from the outside, and from the inside, reality falls apart, just descends into chaos.
And of course, you cannot disprove idealism, right? It's unfortunately in that area where could be true, just seems fucking unlikely to me. And as I said, I put my flag down many years ago as a naive realist, which is there is a reality out there. Magic doesn't work on physical reality. And it's not because we all agreed not to change it, it's because it's just a different thing. It's not a realm in which magic can apply. Magic is a null category in the actual physical world. In terms of our symbol space, yes, you can believe in magic and you might actually think about the world differently. Think about people who go to casinos and believe in luck, for instance, right? And I know many such, right? And yet we all know that if you look at games of true chance with large enough N, there ain't no luck. You know, the house always wins in a highly predictable amount. In fact, people have even done experiments. I love this one where they track the win and loss records of a group of nuns that went to a casino and a group of ex-convicts that went to a casino. And guess what? They both won and lost at exactly the same rates once N was large enough. So, you know, these mind viruses that attempt to claim that they can manipulate the universe but can't are a specific example of what I might call malware that the human brain is susceptible to, very, very susceptible to. Just think of the nonsense that's loose in the world today about COVID-19, for instance. But, you know, I do believe that we can use a sharp enough knife and say, you know, this is just not true about reality.
So the occultist might say to you, Jim, you've locked yourself into a reality in which you will never win the lottery because you have made that commitment in the way that in which you constitute your relationship to reality, that you can never beat the odds, right? That magic is not possible. And it's hard to say whether that's true but when you compare the hypothesis from the outside, you can basically see which one leads into a consistent model of reality. You can, of course, always perform magic. Imagine you run a company and everybody in the company is depressed because the numbers don't add up and they are pointing towards doom. And then you hire a consultant and the consultant performs magic and changes the benchmark. And suddenly everything is awesome again, right? So you pay the consultant and now the question is, what's happening to your company? Did the consultant impose a better model on your company by which it tracks its performance in a better way and regulates in a better way? Or did they just cheat? And this is the issue with magic, that a lot of magic comes down to cheating. Of course, you can edit your memory and your expectations and your interpretations of what happens in between. But it might also change the way that what you feel like. For instance, even if you feel terribly, you can just imagine that you are basically a king that presides over an awesome kingdom and that tomorrow is going to be awesome again. And this is just a very, very short intermission that does not actually mean anything. And this moment, if you look at it from this perspective, is actually quite bearable, right? From this perspective, you're probably going to be a much happier person. But of course, the question is, in the long run, how well do you track reality?
Yeah, let's say, for instance, you decide that I am the king of infinite space, and I decide I'm not going to work and I'm not going to do anything, and then I'll end up starving to death, right? So at the end, reality bats last, And again, in terms of public affairs, you can claim that COVID-19 is a hoax, but that doesn't stop the virus from doing its thing.
Yes. Of course, you can also do the opposite. For instance, since my early youth, I think it was early teens when I stumbled on the same thing as Greta Thunberg did, which the limits to growth and the environmental pollution that was on a one-way trajectory, and the fact that we didn't have regulation mechanisms implemented in our civilization that could make it sustainable before it breaks down. And that seemed to be an obvious thing, right? That we are instigating dynamics that, when unchecked, will lead to the demise of our civilization. And our main defense against that is visual thinking. And once you realize that, you get depressed, right? It's terrifying. And the same thing is also true when you look at society. You mostly focus on the things that get worse, where institutions get senescent, where people defect from what they should be doing in all levels of responsibility. And everything is constantly breaking down and getting worse. And this was my dominant perspective for most of my life. And I must say the world didn't disappoint, right? There was always enough evidence to support this worldview. So I spent my life being extremely worried. I did the inverse to the king that thinks that what you see today is just a short intermission of slightly unpleasant things happening in a life that is overall totally glorious. I basically perceive the world as something that is pretty much miserable, where the past and the future are miserable, and the present is quite bearable, but this is an exception that will surely be corrected in the near future. Right? And this is an opposite distortion that is unhealthy, I think.
Though, on the other hand, I think your analysis is approximately true, as we talked about before, that the current status quo seems to be in a runaway state where it is going to run off a cliff.
Oh, it totally is, right? 2020 is not an aberration. It's exactly the future that we always expected would start to manifest around 2020.
Yeah, and it's starting, and it'll get worse until we do something about it.
But we could have enjoyed the time in between so much more.
That is true. All right. Well, this is interesting. But it's not quite on the main line of the topics I wanted to go through, but it was very interesting. Let's move back a little bit more to some of the specifics of cognitive architectures, the nature of cognitive processing. And particularly, I'd love to talk a little bit about what your views are on the gap between humans and other animals. You alluded to the fact that, elephants have much bigger brains than we do. Whales do too. Some dolphins, killer whales, I think. But we don't see, elephants sitting around philosophizing. And of course, one of the theories, and probably the leading theory, is the difference is that somewhere along the line, we added a new class of object into our brains, something like symbols, maybe, or language of thought, or perhaps it was a more powerful form of procedural memory that allowed us, for instance, to conceptualize multi-part tools. And maybe that was exapted for language, but something in that space. What are your thoughts from examining AI and cognitive science about this only 1%, 1.5% difference in genes between us and a chimp, and yet seemingly a giant gap in terms of our cognitive ability?
So there is an experiment that would be very interesting to make, and this is, how smart can dogs be? There are obviously extreme differences in the intelligence of dog breeds, right? And typically the small dogs that we would like to have in our home tend to be quite dumb. And the dogs that we use to herd our sheep tend to be very smart. But there are the dogs that herd our sheep tend to be less controllable, and they're less suitable as to keep around, because you need to negotiate the relationship to them at a more fundamental level. They're somewhat less domesticated and harder to domesticate. And Homo sapiens also seems to be a domesticated hominid. I sometimes wonder whether the Neanderthals were individually smarter than us, but they didn't have scalable tribes that would scale into states, into societies with unknown numbers of individuals beyond the Dunbar number. And in order to get people to cooperate at scale, you need to domesticate them in such a way that you would selectively dump them down. To dump down their epistemology so they are able to believe the same thing without proof and walk in lockstep.
It's interesting, though I will point out that the confrontation between Homo sapiens, sapiens, and Neanderthal happened when we were still operating below the Dunbar number. That was obviously in our forager stage, at the latest 36,000 years ago. So I'm not sure I buy it with respect to Neanderthal. On the other hand, it's a fact that archaeologists tell me is true, that if you compare modern man to Cro-Magnon man, say 12,000 years ago, at the very end of our forager days, Cro-Magnon man's brain was 10% larger than ours.
Exactly. So what I wonder is if the evolutionary advantage that allowed us to displace the Neanderthals, to genocide them, which is probably what happened, was coordination.
Yep, seems reasonable. Cooperation is the human superpower.
Yes, and it's not just the way we cooperate in the sense that we make a choice individually to cooperate with somebody else, which what cooperation is usually about. It's that we do this without thinking, that we do this automatically.
That's interesting, but again, we're really interested in the line between, let's say, humans and chimps, right, which is much bigger than between Cro-Magnon and Neanderthal. Neanderthal and chimps is gigantic too, just a little bit smaller, perhaps.
Yes. So the main issue seems to be length of childhood, I suspect. The length of our childhood is not so much given by social circumstances. It does play a role, but the main issue seems to be the speed of the maturation of the brain. And what you see is that in ancestral societies, it takes at least 15 years before you are able to forage more than you can eat. And in our society, this period is even longer. Right, so the time by which a kid can basically earn more than it needs in terms of upkeep is typically longer than 18 in our society. So it's a very expensive period to maintain, in which you are mostly doing exploration instead of exploitation. And what we noticed that in this period, it's not just a decision that the individual is making to focus more on exploration. The individual is in some sense literally insane. It has an incomplete model of reality. It has an incomplete architecture. And I don't think this is just not because it has not learned enough yet, but it's like the capstones are missing. It's like the training happens layer by layer, and the infant spends a longer time than a cat infant to learn basic spatial relationships and learn contrast and object permanence and so on. And then it spends a longer time on engaging with social relationships and so on. So you'll find that a house cat, can have a better model of the social reality in the family and the capabilities and relationships of the individuals between them than a 2-year-old baby will have, right? And that's despite the baby obviously being in some sense much smarter when it comes to spatial reasoning and so on, even at that age, and definitely in terms of using language, because most 2-year-olds do have some kind of language that far surpasses what a cat can do. And so it seems to me that our ability might be a conjunction of slightly larger brain and optimized architecture, but mostly more training data per layer when we bootstrap our brains. So we can make better abstractions. And that would be a very simple genetic switch. So you could have a genetic switch that basically delays childhood, every phase of it, makes it slower, and as a result gives you smarter chimps at the expense of longer childhood, which means that chimps need to have much better environmental circumstances and more benefit from exploiting these circumstances, especially. So I suspect that moving into temperate zones where you have a benefit from planning ahead, so you can make agriculture and decide that if you put stuff in the ground now, it might sprout. And if you keep a certain fraction of the stuff that you will not eat as seedlings for the next year or for years in which you have less vegetation coming, all this planning ahead and so on is going to give a huge benefit to a long childhood. It allows you to generalize over very, very long time spans.
Interesting. And then, of course, humans, this is just one of these just so stories about evolution, so it may not be true, but one of the theories is that once we started standing on 2 feet, bipedalism, it produced evolution that constricted the opening of the pelvis that limited the size of the head of the human baby. And hence, while there was seemingly something going on with rapidly increasing brain size, our brains are almost 3 times the size of a chimp brain, even though we have similar body size. We're a little bigger body size, but not anywhere close to 3x. The constraint was the pelvis arrangement in the bipedal method of getting around, and hence the evolutionary adaptation was to be delivered very, very, very prematurely, so that we required a much longer time to fully develop our brains, unlike actually the model animal I use in my cognitive science work is a deer, white-tailed deer. And white-tailed deer is fairly competent 2 hours after it's born, right? It can get up, it can walk around, it can find its mother, it can flee from prey, not very well, but at least a little bit. Compared to a 2-hour-old baby, can't do a damn thing, right? Because the deer pelvis allows a much larger baby relative to the size of the mother. And they have not been under evolutionary pressure for really large brains either. So maybe that is the causal factor of this very long learning process, which is interesting. It's a very interesting point you make about however we got there. The fact that we have a very long maturity period would tell us that we have more training cases to run, more layers to build, and more abstractions. And that's interesting.
Having a large brain is super nice. I also see some people that are obviously super smart, like say John Laird and Stephen Wolfram, but also have extraordinarily large skulls. So it seems to be possible to have a little bit more leeway in the human pelvis to get larger skulls out there, and sometimes it also has good results. We also find people that have brains that are similar to, say, a gorilla brain. And these people are not necessarily mentally impaired in any way. They can hold down a job. They often study at university and can be reasonably smart people, right? So the size of the brain is not absolutely everything. There is a certain leeway in which you can use it. And it's probably nice to have a brain that scales up better. But I don't think that brain size by itself is the deciding factor.
What about the theory that symbols or language per se is the bright line?
Yeah, I wonder about this. It's a very tempting idea. And it seems to be that the ability to do grammatical decomposition is something that distinguishes the ability of humans and other apes. Right? So, for instance, elephants don't seem to be able to produce new images. So they can learn to draw. And what they will apparently do is, at least on the instances that I've seen so far, they don't generalize. They don't make a portrait. They don't capture a new scene. They will produce the same image stroke by stroke again and again. They can learn to do this. They have extremely good motor control, but there is no obvious generalization and observation going into the thing that they draw. It's not a symbolic depiction the same way as we do it. And if you look at the gorillas that have been raised in environments that they were exposed to human-like stimuli and human-like familial structures and so on, they did get, in many ways, to be more similar to humans than many people thought possible. But they also didn't do the grammatical decomposition. So when Coco draws a dog, it looks like Jackson Pollock. It's basically an arrangement of colors that seem to be related to what she was looking at, but you don't see the decomposition of the dog into limbs and a torso and a head and the arrangement of the parts in it. This has not been properly reproduced. It's tempting to think that the lack of a grammatical decomposition in visual scenes corresponds to the lack of the ability of the gorilla or the chimpanzee to use grammatical language.
And it may be that grammatical language, because it's such a compression, right? If we don't have symbols, we don't have something like at least partially recursive language, and we have to manipulate images only, which is at least one argument about what's in the brain in the pre-human era. The density and ability to manipulate easily images is way less than symbols. Symbols are tiny, right? The concept of dog, even if I don't have a word for it, I don't have written language, a conceptual dog is much smaller than many, many images of many, many different dogs. And so having symbols may just make the brain exponentially more effective.
It's an interesting question also if there is a continuum between human intelligence and ape intelligence rather than a sharp cutoff.
What I've read, it seems to be, it's not sharp, but there's a big, big gulf, right? As you say, you can teach Coco to put together very simple linear sentences, but nothing at all like a recursive sentence.
Yes, but of course there are human beings with developmental deficits that have a similar cognitive capacity, right? So there are certain syndromes where the brain does not develop in the same way as it does for the others. And the question is, what exactly are the differences? Are these all pathologies? Of course they are in some sense, because our genetic code is the same for the most part, and they're just local changes in the genetic code or in environmental conditions that prevented development to the specification that we are normally evolved to. And yet, if you look at the differences also between human beings, I noticed this as a tutor in computer science, that the performance that people achieve as programmers can often be predicted very, very early on, depending on the kind of abstractions that they are making in the first few hours when you are confronting them with certain ideas. And there's basically a hierarchy of concepts that you could see in computer science, say from variables to loops to pointers to functions to closures. Each of these concepts basically requires more and more inversion and abstraction, more and more pointers that you need to keep stable in the same representation. The more abstract these concepts become, the harder it is to teach them.
Yep, that is very true. I found that same thing. In my technology career, I hired, 1,000 software developers perhaps, and I got to be very, very good at it, right? I'm a pretty damn good programmer, but I know many better ones. But I do have probably a better theoretical basis in computer science than most. But I was able to recognize at a very high level by asking relatively few questions where they stood on this hierarchy of understanding and the ability to grasp increasingly abstract software development concepts. And you're absolutely right. An hour conversation, I could predict at about 80 or 90% level of confidence how far this person would go in their career.
And there is this thing that most of these concepts can be taught. It's just the amount of time that it takes to teach the concept is very variable.
Yep. And realistically, you only have a budget of education, period, right?
Yes. And realistically, the individual also has a few decades.
Yep.
Right. So if you are able to just learn 5% better than somebody else, this is going to compound. And so I'm totally envious when you look at Stephen Wolfram, who understood things at 22 that I understood in my 40s.
Yep, I certainly saw that in my dealings with the people at the Santa Fe Institute. In the business world, I was almost always the smartest guy in the room. At the Santa Fe Institute, I am almost always the dumbest guy in the room, or damn close, right?
Yeah, these are great rooms.
Yeah, those are great rooms. As I said, that's not quite true. But in business, I was definitely in the 99th percentile. In the world of complexity science, on a good day, I'd be the 25th percentile. And you learn so much so fast, but you also come to appreciate that there are people who just operate at a very different level of abstraction, which I will never be capable of. But that's okay.
Yeah, these people make me very happy.
I'm glad they exist. I like them a lot. And frankly, I spent a fair amount of my effort making their life better, right? so they can do their work. Let's now switch a little bit. Let's move down some in the stack of abstraction. In your writings, particularly in the book, you talk a fair amount about cognitive architectures as an approach to, we talked about at the very beginning, thinking about the brain through software in ways that may help us understand ourselves and, by the way, maybe do practical things, but at least understand ourselves better. Could you maybe tell for our audience a little bit about what cognitive architectures are in the sense, things like SOAR, ACT-R, and the Psi model, and how they differ from what we read about in the newspaper all the time, the machine learning, deep neural network approaches?
Cognitive architectures are a tradition that mostly originated in psychology within people that were strongly influenced by the ideas of cybernetics and AI, and then decided to get real about this and try to get a look at the way our mind is structured, because our mind obviously has a lot of structure, to identify the architecture of our mind and then identify the principles that would need to be implemented. And I think that most people in the field of AI would agree that there are two directions that we need to look into. One is the general principles of learning and functional approximation. So when confronted with data, how do you efficiently build a model over the data that allows you to predict future data and interact with it and build control models? And the other question is, in which particular way is this organized in the human mind to give rise to the particular feats that humans have, like learning language, interacting socially, interacting with the environment and with their bodies, to reflect symbolically over their perceptual representations, such as feelings and so on. So how to get these two perspectives together is for me a very interesting and challenging question. And most of the work that is being done in machine learning is not looking at architectures. The architecture is only instrumental to a certain task, which could be, for instance, text completion. So we think about how to organize structure into layers and then how to stack the right number of layers together, or maybe implement an algorithm that automatically searches for the right number of layers. But we can also see that the brain is not organized into layers. It's organized into regions that have very complex interconnectivity, right? So it's much more like a city with a rich set of different ways of transporting information around in it, right? So there is going to be some street network that is low level where you can reach your immediate neighborhood. And then, but it's quite pedestrian and it takes longer for the signals to cross large distances. And then there are long range connections like a subway. And then there is some general interconnection network that goes via the thalamus and allows for information from basically every region in the neocortex to get to every other, to route information around. And so how that works is a very interesting question to me. You could also look from a perspective of training a network in some layer by layer, and then as soon as you introduce a new layer, you make this a function of the existing layers. And once that thing is trained, you introduce recurrent links. So the predictions of a later layer in your architecture are going to inform the predictions of the earlier layers and become inputs to them, right? So they become the context in which the lower layer makes its next prediction. And the result is the same. So instead of getting a nicely tiddy hierarchy of things where you have an input and an output, and the input is your sensory apparatus and your output is the highest layer of your attention, it turns out to be fully interconnected and going every way backwards and forwards. And suddenly your visual cortex is not the first stage of processing. It's just the area where you store the textures.
Yeah. And of course, that seems to be how the human mind is structured. And, when I react to deep learning, mostly feed forward, though they're now adding some simple recursion, I always ask myself, what are they missing by not having these feedback loops?
I think that everybody is aware of the fact that they want to have recurrences right from the start. When you look at the original work, for instance, by Hinton and Zanowski and Ackley on Boltzmann machines, that you have already a very, very general form of a model that understands that a model is a set of parameters that constrain each other. And each constraint is a computable function that says if a parameter has this and this value, the influence that it has on all the other parameters in the model. And then you can say that the deviation from these constraints is energy, and you minimize the energy. So it's very similar to a spin glass model in physics, where you try to minimize the global energy state of the system. And when you achieve that, the system converges to an interpretation of reality. And in some sense, theoretically, this works very well. As a model, it's pretty close to optimal. But it's impossible to train, it turns out, because the search space for these variables and constraints between them is so dramatically large. It's basically not trainable beyond a few parameters. And so Hinton introduced a constraint on this. He said that instead of having all these natural links between the parameters, all these hidden links, we only link them in a forward manner, and in between the parameters, we don't have links. It's what's called a restricted Boltzmann machine, RBM. And of course, suddenly this thing cannot model many things anymore. And the solution to that was to string many of these RBMs together in a network. So each of them is individually trainable, even though it's limited. And overall, it produces behavior that the individuals could not. And this eventually leads to our current deep learning architectures via a few steps. But it's not optimal, right? The search space is too large. There are too many model states. The ideal model should be able to be so tight that every model state corresponds to a possible state in reality. Most neural networks have many magnitudes more possible model states, which gives rise to adversarial examples and limits generative creativity, because most of the states that the system can be in will not correspond to a world state, right? So for me, the thing that a lot of people don't pay enough attention to is what this transformer model is achieving. It seems to be a way to think about embeddings into a space of features in a more general way. So it gets back to this original notion of the Boltzmann machine from in a different projection, from a different perspective, but still. And it is this notion of attention and self-attention binds features together across the dimensions into a relational graph. And this allows you, for instance, to generate a text in which a noun and a pronoun are associated over a very large distance, or where the initial part of the text mentions the person by name that performs a scientific experiment, and the later part of the text just refers to this as the scientist or the researcher, and uses them as synonyms, and understands in some sense, or represents, that all these entities refer to the same concept in the text, right? This is something that was very hard to achieve in previous neural network implementations of language. And it's striking that this doesn't only work for text, it also works for images. So you can train this on images, and you feed it the first few lines of an image, and it's going to continue the image, which implies that internally, while predicting the image, it's building a representation during the prediction of the next thing of the entire image until the end, right? So that's a tremendous achievement. It seems to open the door to embeddings in general across all modalities. What happens if you are not just modeling the perception of a system like this, but also its decisions? Is there a difference between making a decision and predicting your decision? It's probably the same thing, just from a different perspective, right? There is still going to be some differences in terms of the way we predict reality, because we do not predict reality just from the past. We also predict reality from the perspective of the future that we want to have. So we limit our search space to certain results that we want to have achieved in the end. And this is a thing that the way we access the GPT-2 class or transformer class of models currently are not doing. But it's nothing that is inherent to the way these models are constructed. It's just inherent to the way we're currently using them.
That's very, very interesting about where we may be able to go in using transformer-based architectures to get back to, the ability to do things at long range.
And, the transformer architecture is still a hack if you look at it. It's a very simple idea, of course, a very smart, simple idea that is then scaled up to see how far it can go. There's not an obvious limit that we have hit yet to how far it can go, which is in some sense terrifying because it's so simple. And you immediately wonder what are the optimizations going to be that we will quite inevitably discover in the next few years.
Yep, that'd be very interesting. We'll have to keep a look on it. We're getting long on time here. We've kind of gone over our time limit, but that's okay. I'd like to drill down a little further into details into some of your own work now. Let's maybe give it another 10 minutes if we can, and talk a little bit about the psi theory. Dietrich Dörner, is that the guy's name? Mm-hmm. Who came up with it? And you wrote the very interesting book on the topic. And one thing I found interesting about it was that it was connectionist, but the elements in the connection architecture, while they all use the same architecture, could be at varying levels of abstraction from quite high to quite low. And, the system self-organized and hierarchical, all that stuff. So anyway, if you could explain how all that works.
Dietrich Dörner is a German psychologist, a cybernetician, strongly influenced by these ideas in the 1960s. For a while shared a desk in the Hanse Kolleg with Stanislav Lem, who became a good friend of his. And at some point, their directions diverged, even though they remained friends over the years until Lem died. And Lem decided that the biggest influence that he could have on the development of artificial intelligence in cybernetics would be to become a philosophical science fiction author, because he would be free of the constraints of academia and to actually get things to work, and instead anchor ideas in the minds of people that would have a larger influence than writing a few papers about systems that he would not be able to get to work in the next decade or 2 decades. And Dörner was more optimistic. He thought that behavioral psychology, which was all the rage at the time, is not cutting it. And instead, we need to do cybernetic and computational psychology and just implement a model of how people work, and then we'll be done. And he thought that he'd be done in the late 1970s originally, and told his wife that they would have an awesome time on the beach after that, because their job would be finished. We would have computers that think and solve all our problems for us. And of course, that didn't quite work out. But he, mostly on his own, reinvented or invented in parallel many of the ideas that AI was into. So he started out with monolithic systems that later became situated, connected to an environment, and then this environment could be changed by the system, so it became an agent architecture. And then he invented multi-agent architectures. And all the while, these architectures had models of autonomous motivation in them that were based on this cybernetic idea of a feedback loop that would regulate it all. And what I liked about his work was that he was extremely serious about building minds, and his heart seemed to be in the right spot, and also his ideas seemed to be on the right spot. So when I started reading his ideas in the 1980s, most of the psychologists ignored him because it was theoretical psychology. He, for a long time, had the only chair of theoretical psychology in Germany. There was no such thing as theoretical psychology. And that basically tried to bridge between AI ideas and psychology, while he was mostly unaware of the discourse that would take place in AI. And he would read sometimes something about it, but always come up with his own solutions. In the first interview that I read with him, a very consternated journalist of the German magazine Spiegel, which is the equivalent of the Times in US, asked him why he would claim that these systems have true emotions. Wouldn't everybody understand that it's impossible for a computer to have emotions? And Dörner replied very earnestly that it really depends on your definition of emotion, and that if you have a definition of emotion that doesn't have an extension that you can understand, you probably don't know what you're talking about. And then he went on to try to define emotion, and then try to explain why his systems would have emotion in this sense. And I agreed with him. And while I thought that this notion of emotion does not capture everything that emotion captures for me when I define emotion, it seemed to me that there is a trajectory along which we can make this definition richer and extend it, and then implement all these missing things until we all agree. So I thought this is probably the way to go. And I started reading all his stuff, and then decided to systematize it and translate it into something that could be actually implemented. And because I was less bold than him, I took his psi theory, this letter that psychologists love to use when they make a theory of everything, and translate it into micro-psi, my humble attempt as a computer scientist to get some of the concepts at least to work. And I spent almost a decade with that. And this book, Principles of Synthetic Intelligence, is an attempt to turn the psi into an acronym for a book title, of course, and to systematize his work and make it accessible to people in cognitive science and artificial intelligence. So this is what the first third of the book is doing: summarize Dörner's ideas and systematize them, contrast them with ideas that were around in the field compared to related work. And then the second part of the book is implementing these ideas. And the third part of the book is critiquing them and explaining where I think we need to go beyond them. And this is a snapshot of my understanding back then. And my thinking has since then in many areas evolved a great deal. And moved on. It's not that I still think that now think that these are bad ideas. It's just this would be the first third of the next book that I would write if I find the time.
Okay. Interesting. And what is the status of the MicroSci project? I saw there was a MicroSci 1, which ran only under Windows, and then there was a MicroSci 2 that was written in Python. But I looked at the GitHub project, looked like there hadn't been any updates on it in 4 or 5 years. Is anybody working on it? Is it being used at this point?
Yes. So the first MicroSci, we always try to be platform independent because the people that I worked with, they had Macs, they had Linux, they had Windows, and we wanted to make this accessible to anyone. So the first one was done in Java and was written directly as a plugin to the Eclipse IDE. And it was using all the typical things that you would use in 2003. So lots of XML and lots of factories. And I think that back then it was respectable software engineering, but it was very different from what we would do 5 years later when everything was going to be Python and you would put your UI in the browser. So the way to make a platform independent implementation of a research cognitive architecture was different when we did the second edition. And the second edition was being used in 2 startups. One went defunct, was an AI planning startup. The other one was started later by students of mine mostly. I'm also a co-founder in this. It's called MicroSci Industries and uses the MicroSci architecture as a framework to implement control networks for industrial robots mostly. And also does a little bit of basic research, but most of the things that are done are in-house. So while we still host the architecture for people that want to use it, and some people use it and play around with it, the main evolution takes place within the company for proprietary projects in Berlin. And at the moment, I am using MicroSci internally for trying out certain models that I have about using spreading activation networks to produce procedural strips that interact with cellular automata, representation and processing layers. We're also thinking about what the next edition of MicroSci is going to be and how it's going to be implemented. And we have some ideas about this, but it's too early to talk about this.
Okay. I was going to see if I could get you to talk about what MicroSci 3 might be looking like. I'm going to throw out some ideas, which I'm always throwing at Ben Goertzel about OpenCog, which is, I hope when you do it that you think big. So many of these cognitive architectures or AI platforms were unfortunately conceptualized to only run on a single machine or a small cluster. And one of the things that we now have is really cheap computation and really fast networks. And if I were designing a platform for thinking machines, I would look carefully at some of the Apache large scale, very big cluster, very large throughput platforms like Ignite and Flink and Spark. It has 2 big advantages. One, that they operate at massive scale. And secondly, it gets the implementer out of having to write a whole lot of low-level stuff. And so you can leverage your manpower in the higher levels of the actual value add rather than trying to optimize how you move pointers and things of that sort. These guys have already figured that out.
Exactly. I also wonder whether we should still think so much of within system and more across systems. So instead of thinking about how we can make a representation that is completely homogeneous, think about how different parts of the architecture implement general principles that allow them to learn how to interact with all the other parts. And if that happens, you can, for instance, instead of reinventing linear algebra on a GPU that then reinvents how to render graphics on the GPU using linear algebra, you can, for instance, use existing shader programs and graphics engines and learn how to use them instead.
I think that's right. And again, there is no free lunch. So people say, oh, yeah, well, you have Ignite, a true gigantic key value store. Well, guess what? On distributed architectures, there is no free lunch, right? Queries that have to traverse the network have very different costs than ones that don't. And so having a system that can self-organize to take advantage of the realities of its network is probably the real secret to maximize these super powerful, gigantic scalar tools. But using them naively, you can produce degenerate queries quite simply that, yes, you have 100,000 processors, but guess what? It's still slow because the data is all over the place that makes any single query inefficient. So these things are by no means panaceas, but if I were going to go down that road, I would be thinking of these very large-scale data processing architectures rather than writing something to run on a single machine or a small cluster. Well, this has been a very interesting conversation. We went a little bit longer than I was thinking. We didn't get to some of the topics I had on my list, but that's okay. I think our people will find this to be a quite interesting deep dive into the mind of Joscha Bach.
Thank you. I really enjoyed our conversation, and I'm sure we have more topics left for future time. Thank you very much.
Production services and audio editing by Jared Janes Consulting. Music by Tom Muller at